Now in this lecture, we are going to look at big picture of time and space complexity of stack using linked list. Now here, we have combined all operations that we performed on stack in case of linked list together to see the time and space complexity in big picture. Now the first operation is creating stack. Now when we are creating stack using linked list, in this case, we are just initializing the head reference. So in this case, this will take O1 time complexity. Now the space complexity also will be O1 because here we are not inserting any element to the stack over here. Now the second method is push method. Now when we are pushing element to the stack, we are inserting element at the beginning of linked list. Now we know that when we are inserting an element at the beginning of linked list, it will take O1 time complexity. Now in each time when we are pushing elements to the stack, we are going to push one element, so that's why the space complexity will be O1. Now the next method is pop method. Now pop method works the way that we are returning top element and we are removing that element from the stack. Now in this case, in case of linked list, we are removing the first element from the stack and returning that element to the console. Now in this case, we know that removing first element from single linked list takes O1 time complexity because in this case we are just changing the reference to point to the second node, so that's why it takes O1 time complexity. Now when we are deleting an element from the stack, it will take O1 space complexity because here an extra memory is not required to perform this operation. Now the next operation is pick method. Now in case of pick method, we are returning on the top element without removing it. Now in this case, we know that in case of linked list, the top element will be always first node in the linked list, so that's why returning first node will take O1 time complexity because in this case we are just returning the value of head over here. Now it's obvious that space complexity for this operation is O1 because here again an additional space is not required to perform this operation. Now the next method is empty method. Now we know that when we are checking the stack in case of linked list, we are just checking the head reference. So if head points to the null, it means that our stack is empty, otherwise it's not empty. Now in this operation, we are just checking the head value, so that's why it will take O1 time complexity. Now the space complexity is obviously that it is O1 because in this case, based on the head reference, we are just returning true or false, so here an extra space is not required. Now when it comes to deleting the entire stack, it will take O1 time complexity because in case of linked list, all we are doing is we are just setting the head reference to null. After this, all nodes in the stack becomes eligible for garbage collection because these are not referenced by any node, so that's why it becomes eligible for garbage collection. So that's why they are going to be deleted from the memory by garbage collector. Now the space complexity obviously is O1 because here we are deleting the all elements from the memory, so an extra space is not required to perform this operation. Now with this, we have finished the stack using linked list. Till now, I have explained these operations and show you how they are working in the memory, and we have implemented them in practice successfully. Now, hopefully everything is clear about these methods over here. Now, see you in the next lecture.